All right, so let's move on to question 2. So it reads, R and S are two allotropes of carbon. R is a black opaque solid, which can be described as flaky with a melting point of 3,925 degrees Celsius. S is a reflective, colorless solid with a melting point of 3,823 degrees Celsius. First, define the term allotrope. So essentially, allotropes are different structural forms of the same element. So let's write that. So allotropes are different structural forms of the same elements. They have different physical properties, but similar chemical properties. They have different physical properties, but similar chemical properties. Okay, let's see. I can write that chemical properties. Right. Then identify the names of R and S. We know that R is, of course, graphite, because based on the properties that they describe to us here, and S, of course, is diamond. State whether R is an ionic, simple covalent, or giant covalent structure. Of course, R, just like diamond, just graphite, is a giant covalent. So then it asks us, in the space below, sketch the structure of R using solid lines to show strong bonds and dotted lines to show weak bonds. So this is something that you need to know how to draw. Let us know that it's hexagonal shaped. You need to know to draw it properly, not like me. So essentially each carbon atom then it says, in the space below, sketch the structure of R using solid lines to show strong bonds and dotted lines to show weak bonds. So we know that in graphite you have layers of hexagonally shaped bonds. And each carbon atom, let's draw those first. Let's draw about 5 or so. And let's draw next one here. Alright, let's draw another layer below it. So we can show our weak bonds, van der Waals, versus those are weak bonds. It's like essentially, let's show a carbon. Each carbon atom in the graphite is bonded to 3 others. Let's put those in. They're bonding covalently to 3 others. All of those. And each layer is bonded via van der Waals forces, that is said to show these are weak bonds with the dotted lines to each other. So let's show that. Let's use another. Let's use red. Dotted lines. Right. So these are our weak bonds. Our van der Waals forces. Wall. And of course, these are covalent bonds. And that's graphite, right? Then the next question says, explain why R conducts electricity, but S does not conduct electricity. So in graphite, as I stated before, three, each carbon atom, right? Each carbon atom can accommodate up to 4 bonds, right? But in the graphite, each carbon atom, bonds covalently with 3 other carbon atoms. 3 other carbon atoms. And then that leaves a free electron, free mobile electron, carbon atom, which leaves a free mobile electron to conduct electricity, right? Electricity. However, S in R, there, that's graphite. However, in S, which is diamond, each carbon atom is bonded to 4 others. Therefore, no free electrons exist. Free mobile electrons exist to conduct electricity. Yes. Another solid T is white in color with a melting point of 801 degrees Celsius. Conducts electricity when molten but not in solid state. So they gave us 3 clues. White in color, melting point of 801, conducts electricity when molten but not in the solid state. Deduce the type of bonding present in solid T. Of course, the type of bonding that is present is ionic bonding. And this is a clue. It conducts electricity when molten but not in solid state. So essentially, ionic bonds in ionic compounds, in the solid state, the ions are in a fixed position. They're not able to move. The ions, which are the charged particles, they're not able to move to conduct electricity, right? However, when they're molten, they're free. And hence, the ions are able to conduct electricity when in a molten state, but not in a solid state. State the appearance that solid T is expected to have. Now, of course, I already told us that it's white, right? So in this case, you can just put that it's crystalline. So next question states, solid liquids and gases are easily converted from one state to another. Compare the arrangement of particles in solids with the arrangement of particles in liquid. So essentially in solids, the particles are closely packed together. However, in liquids, the particles are randomly arranged. Particles. So in solids, the particles are closely packed together, and this gives them a definite shape. So it's packed together in a specific way. Over in liquids, the particles are randomly arranged. Randomly arranged. And they have spaces in between them. Arranged with spaces between them. When solid iodine is heated, a purple color gas is observed. State the process which occurs and give one example of another compound which undergoes the same process. Now, this process from solid to gas, of course, is sublimation. Right? And another compound that undergoes sublimation is ammonium chloride. Ammonium chloride. Right.